We're going way behind the pharmacy counter into the world of pharmaceutical manufacturing.
Behind the scenes, literally.
Exactly, and today we're focusing on these places called central utility buildings, CUBs for short, and these kind of mysterious technical floors.
Trust me, these places are way more interesting than they sound. They're like the unsung heroes of making medicine.
Right. From all the research we've done, it's clear that making medicine isn't just about, scientists in lab coats.
This whole system.
It takes a whole hidden system, and the CUB, this central utility building, that's at the heart of it. It's like we saw boilers, chillers, air compressors mentioned. It sounds more like a city's infrastructure than just a building.
That's a great comparison, actually. Just like a city needs its power and its water, right? Pharma manufacturing, it needs incredibly precise conditions. We're talking even a small change in temperature or humidity that can mess with a medicine's quality, make it unsafe even.
Oh, wow. So it's not just like keeping the lights on in the building, it's about making sure the medicine actually works.
Absolutely, it's critical.
The central utility building,
The CUB.
the unsung hero of pharma, you could say.
Totally. We've got this super technical document as our guide, and let me tell you, the CUB might sound boring on paper, but it's what keeps those factories humming 24/7. So why don't you break down why the CUB is so crucial?
Well, think of it this way. Every single thing in a pharma plant, from the lights to the machines mixing ingredients, needs to be perfectly controlled, right? The CUB is what makes sure that happens nonstop.
So it's kind of like the heart and lungs of the whole operation. Exactly. Imagine a power cut, right? Normal building, that's annoying. Pharmaceutical plant. Could ruin entire batches of medicine.
Which is a huge deal, obviously.
Huge. But the CUB's got backup generators to instantly kick in. That's just one example of how it keeps things running smoothly no matter what.
Okay, so this CUB is sounding less like a boring building and more like a superhero's lair. What's actually inside this thing?
Oh, it's a whole symphony of systems in there. This document lists 10 key ones. You've got your boilers and chillers, which, no, these aren't your average water heater and AC
I
unit.
was about to say, that doesn't sound too exciting.
Not even close. We're talking precise temperature control, and I mean precise. Some medicines, they're made with live bacteria cultures. A few degrees too hot or too cold, and the whole batch is toast.
Wow, so the CUB is basically the stage manager for these finicky little bacteria actors, making sure their performance goes off without a hitch.
That's a great way to put it.
Speaking of perfect environments, what about air compressors? I get keeping things cool, but what's so special about the air?
We're talking air purity on another level. They filter out dust, microbes, stuff you and I can't even see. Even the tiniest speck of contamination could be really bad news.
Oh, air purity. Never thought of that being that vital for making medicine.
Oh, it's crucial.
Makes you realize how much care goes into every little detail.
Absolutely.
Now, you can't have all this high-tech stuff without a nervous system to run it all. That's where our electrical panels and transformers come in, right? Making sure the power gets where it needs to go.
You got it. And in case the main power grid goes down, the CUB's got the backup singers warmed up and ready to go. The generators kick in so fast you wouldn't even notice a flicker.
Those generators are like the understudies you never knew you needed, but you're sure glad they're there when the lead singer gets a cold.
Exactly.
All right, so we've got temperature, air, electricity. What about the, shall we say, more basic plumbing needs?
You mean the fire water and regular water supply systems?
Well, that and, the other stuff.
Right, well, those systems are obviously vital too, but for this episode, we're focusing on the systems that directly impact the making of the medicine. Just like with the air, the water used in the manufacturing process has to be incredibly pure.
Right, of course. So, like a marathon runner guzzling water, the facility itself needs to stay cool. Cue the cooling towers.
It just occurred to me. We've talked about the CUB keeping the air and water pure inside the facility, but what about the stuff that goes out?
Ah, good point. That's where those effluent and sewage treatment plants come in, right? Making sure nothing harmful gets released.
Exactly. It's all interconnected. Waste is treated super carefully, ensuring the whole manufacturing process is safe and doesn't impact the environment.
So we've got temperature control, air purity, power, water, and waste management, all happening thanks to the mighty CUB. It really is like a hidden world working behind the scenes to make the medicine we rely on. But why should we, the everyday pill takers, care about all this?
Because the CUB is the silent guardian of your medicine cabinet. It guarantees those pills and injections are made safely, effectively, and are ready when you need them. That level of reliability. You can thank the CUB.
Wow. And speaking of things that have to be super precise, our research mentions something called water for injection, WFI.
WFI, yep.
And I'm guessing we're not talking about, just turning on the tap.
Not even close. Think about it. Injecting medicine right into your bloodstream.
Yeah.
Even the tiniest bit of something bad in there, that's dangerous, right?
Yeah, that's scary when you put it that way.
That's why WFI exists. It goes through this insane purification process to be as pure as possible, like seriously pure.
Wow, okay, that definitely puts things into perspective.
Yeah.
So how is WFI different from, I don't know, like the filtered water we drink? Is it just like extra filtered?
Okay, so think of it like this. Your regular water filter at home, right?
Yeah.
That's getting rid of some bigger stuff, maybe. But WFI, it's on another level entirely. We're talking removing bacteria, viruses, minerals, even things you can't see or taste. It's a whole multi-step process. They use things like distillation, reverse osmosis.
That's or osmosis, I've heard that term.
Basically, they force the water through these incredibly fine membranes. So fine, they trap even the tiniest contaminants. Anything that could be harmful.
Wow, that is some serious water purification. But even then, they're not taking any chances, are they? I read something about them actually circulating the WFI at high temperatures.
You do. It's like, how you leave leftovers out on the counter too long?
Oh yeah, bad news.
Exactly. Same idea here, but with super pure water. They keep it constantly flowing in a heated loop.
So it never just sits around.
Exactly. That's how they stop any bacteria from even thinking about growing in there. It's pristine until it's needed.
Wow, it's like a constant game of keep away, but with any possible contaminant.
You got it.
So we've got this super clean water, but that's just one part of the puzzle, right? We also saw this term technical floors, and honestly, it sounds kind of mysterious.
A little bit, yeah. Think of it like this. The nervous system of this whole operation. Hidden above or below the main manufacturing areas, packed with pipes, ducts, wires, all connected to create this really carefully controlled environment.
So it's like a whole network dedicated to keeping things clean and organized, like a giant super clean bubble around the medicine.
Exactly. And a really important part of that bubble is how those clean utilities, like our super pure WFI, how they even get transported. The source material highlighted that they use stainless steel piping.
Stainless steel? Why stainless steel? Is it just about being super durable?
Durability is important, don't get me wrong, but the main reason is how smooth it is. Yeah, think of a brand new frying pan. That's the surface we're talking about here. Stainless steel is so smooth, bacteria really struggle to latch onto it, and in this environment, that's absolutely crucial.
So every single detail matters. The type of water, the material of the pipes. It's amazing how precise it all is. Speaking of precision, those technical floors, can we dig a little deeper into those? What's actually happening up there that keeps those manufacturing areas so clean?
Well, for one thing, they house these amazing air filtration systems called air handling units, AHUs for short.
Okay.
Think of them like giant lungs for the manufacturing area, constantly pulling in air, filtering it, and supplying fresh, clean air.
So not just clean air, but filtered air. What's so special about these AHUs?
It's serious air purification happening up there. These AHUs, they use something called HEPA filters, stands for high efficiency particulate air.
HEPA filters, okay.
They're like the superheroes of air filtration. They trap almost all microscopic particles. We're talking dust, bacteria, viruses, the works.
So they're catching all the bad stuff, but then how does that clean air actually get into the manufacturing areas? It's not just blowing around randomly, is it?
Good point. Remember we were talking about the technical floors being like a super clean bubble?
Yeah, to protect the medicine.
Right, so these AHUs are strategically placed to create what's called directional airflow within that bubble.
Directional airflow. What's the strategy there?
Imagine it like an invisible current guiding the air. So clean, filtered air is constantly being pushed into the manufacturing areas from one direction.
Okay, so it's controlled.
Very controlled. And then at the same time, the dirtier air is gently pushed out in a different direction. It's all about air pressure, making sure that any potential contaminants, they're always moving away from where the medicine is.
Oh, that's really clever. So it's like even the air itself is part of that protective shield around the medicine. Wow, it's amazing when you think about all this detail, all this planning. But contamination can come from other sources too, right? It's not just the air and water.
Oh, absolutely. Even tiny dust particles, or worse, microscopic particles from, say, a previous batch of medicine that could contaminate the current batch.
Oh, right. I didn't even think about that.
That's why they're so strict about preventing what we call cross-contamination.
So how do they manage that? Is it just like being super careful about keeping things clean?
Cleanliness is a huge part of it, for sure. But it goes even further. For example, you might have dedicated equipment tools, even gowns and gloves, specific for each stage of the manufacturing process.
So they're not just using the same tools on everything.
Exactly. It's like, imagine you're baking a cake. You wouldn't use the same spoon for the flour and then for the raw eggs, right?
That's a good point. Yeah, you'd want separate spoons.
Exactly. Same principle here, but with, much higher stakes.
Definitely higher stakes than a cake. So it's all about separating each step, making sure nothing gets mixed up. And speaking of separating things, our research also mentioned something about pipe racks and cable racks. What's the deal with those? Those don't sound very high-tech, I gotta be honest.
They might not be glamorous, but trust me, they're essential. Think about it, all those pipes carrying that super clean water we talked about, plus steam for sterilization, different gases they use in manufacturing.
Right, so it's not just one type of pipe.
No way. It's a whole network of them, crisscrossing above the manufacturing areas. And that's where the pipe racks come in. They keep everything organized, accessible, not just a tangled mess.
So it's like a giant, super organized plumbing system, but for pharmaceuticals.
Exactly. And just like you need plumbing, you've got a whole electrical system to power all this equipment. That's where cable racks come in, keeping those wires and cables neat and out of the way.
It's like the whole system is this giant, complex puzzle, every piece perfectly in place, all to make sure that the final product, the medicine, that it's safe and effective.
Exactly. It all comes back to that.
But it makes you wonder, with so much technology involved, so many systems, how do they make sure it all runs smoothly every single day?
That's where the real heroes come, in the skilled engineers and technicians. They keep these systems running 24/7.
Wow, 24/7, so they're always on call.
Pretty much. They monitor everything, from the temperature and humidity, the air pressure, the water purity, always making adjustments, making sure every single piece of equipment is working perfectly.
It's like they're conducting an orchestra, but instead of instruments, it's all these complex systems.
That's a great way to put it. It really is a symphony of science and engineering all working together.
And the end result is, hopefully, life-saving medicine. It's incredible to think about how much work, how much dedication goes on behind the scenes.